Hello and welcome to Contractor Outlook Newscast. My name is Heidi Ellsworth and we're with the Coffee Shops. We are here today to really talk about something that is on everyone's mind, and that is the weather. Contractor Outlook Newscast is all about that. It's about bringing you weather, politics, economics, whatever is really top of mind to help contractors and their business. So we have asked the expert at Intertek, Alan Scott, to join us today and have a very interesting conversation about heat, hail, wind, water, and safety. So, Alan, welcome to Contractor Outlook Newscast.
Oh, Heidi, it's so exciting to be here with you today and have this conversation. As you mentioned, my name is Alan Scott, and I'm Director of Sustainability with Intertek in our Building and Construction Division. My background is as an architect, and I've been working for more than 25 years as a consultant in the built environment space for sustainability, resilience, and healthy building aspects.
Wow. Well, interesting, first of all. What an interesting career. Second of all, can you tell us a little bit about Intertek? What does Intertek do?
Well, Intertek is a global assurance testing, inspection, and certification company. So we essentially do quality assurance for everything you can imagine, from consumer products and electronics to gigantic equipment and everything in between. Our building and construction division works on quality assurance in the built environment, things like geotechnical and environmental services, as well as concrete testing and rebar inspections, and building science, where we work on consulting, inspection, and testing for high quality building enclosures.
Wow. With everything that's going on in the world right now, with all of the extreme weather that we're seeing, this is more important than ever, what you're doing and really bringing the built environment to meet the standards of that extreme weather that's happening right now. Can we talk a little bit about that intersection of resiliency, sustainability, and smart construction? How it's all, because Alan, we really have a couple things. We have new construction, right? And then it has to meet, but we also have restoration or retrofit that's out there. So how is that all coming together?
Well, that's why I love this part of the conversation, because this is the intersection where I work.
Awesome.
So I think maybe it might be helpful to define what resilience means, because that word's used a lot, but I think a lot of people think about it in different contexts. So in the built environment space that we're talking about today, resilience refers to the physical and operational measures that you can put in place in buildings and infrastructure that increase its capacity to withstand and or recover quickly from adverse events like extreme weather events or natural hazards. So when we think about that intersection, I kind of look at it. There's 3 points I want to touch on. Sustainability is incomplete without inclusion of resilience. Resilience provides sustainability co-benefits, and smart construction makes both of these more feasible. So I'm happy to expand on all those. When we think about sustainability being part of, or being incomplete without resilience, I'm thinking about, there's a lot of concern about embodied carbon in materials. And so that's been a big part of sustainable construction. Well, durability, that's part of resilience, makes sure that the materials we put in and the embodied carbon impacts they have aren't repeated multiple times, so we don't lose buildings to damage from hazard events and have to throw that material in the landfill and put new building in. So durability is part of sustainability aspects of resilience. And so I think that's a key element there. And when we think about then resilience as providing co-benefits and sustainability, one of the deadliest natural hazard events is extreme heat events. And extreme heat events are often accompanied by power outages. So we can't necessarily rely on, I've got air conditioning, so I don't have to worry about extreme heat. So designing buildings that are thermally efficient and with improved building enclosures and maybe with renewable energy systems and backup power and energy storage, provides that thermal resilience in a heat wave when the power is out, but also even when you never have extreme heat events, that those measures reduce the energy use in the building, reduce the cost of operating the building, and reduce the carbon emissions from operations in the building. So there's a co-benefit of sustainability on an ongoing basis and resilience against power outages and extreme heat events. And then finally, relative to that intersection, smart construction, things like prefabrication that might increase durability or the speed of construction or rebuilding after a hazard event. Smart construction using technology to understand the materials in a building so that you have more rapid repairs after damage occurs. Things like that can add both resilience and sustainability in construction.
Yeah, and you know what? I love this conversation, just like you. I think it is a sweet spot of where we need to be moving in the future, because, you know, for the longest time, you didn't hear manufacturers in roofing or in overall construction really talking about the importance of resiliency or redundancy or durability. You know, as you're looking at the whole building envelope of how it can perform, whether that's extreme hail or heat. Like, I mean, when I think about, I'm in the Pacific Northwest and we have heat domes now that, you know, that are actually sun burning plants. And it's just kind of gotten a little crazy. So what are you seeing really with code minimums? I mean, it seems like this needs to be a partnership between private, obviously, you, the architects, the consultants, the contractors, but also, you know, building officials really understanding. So what are you seeing there with code minimums and how they affect risk around the resilience of the property?
Well, yeah, I think that's really important to understand. And first of all, I want to say, as an architect, codes are really important. And I appreciate that we have codes and we need to build, you know, to meet code standards, because they are a minimum level of health and life safety in the built environment. So we need codes. But it's also important to understand that codes are a minimum standard and not necessarily the same thing as resilience. And so a code compliant building can make sure that people don't die in a hazard event, which is important, but they don't necessarily mean that that building will be habitable, that it can be rebuilt easily. And so when I think about resilience, I think that we need to go beyond code in some measures, not going crazy with it, but understanding what are the likely hazards that a building will face and where do we need to go beyond that. You mentioned hail, for example, and thinking about roofing that doesn't just meet minimum wind uplift standards for a location, but understanding which kind of extreme wind events might a location have. Will they potentially be seeing more extreme hail events, and does that building need, or that roof need to have greater durability, stronger tie downs in the roof assembly so that it can withstand both extreme wind and hail events without significant damage.
Yeah.
And, you know, this ties into the architects have a standard of care that they are supposed to inform their clients and design to meet the potential hazards the building might face. And so the architect's evolving standard of care means that architects need to be aware of current and future natural hazard risks to a property, inform the owner about that, and discuss which resilience measures does the owner want to incorporate in the building. So it's not enough for the architects to say, I've designed this to meet code. They need to go beyond that and have a conversation about that.
Yeah. So in your role with Intertek and with what Intertek is doing, you know, staying in tune with the damage that's being done by some of this extreme weather, whether it's the heat, hail, hurricanes, wind, it seems like that would be just a full-time job all on itself, is just to see, because we are, you know, every day you turn on the radio, you're hearing about 100-year storms. And so how are you kind of tracking that and keeping up with all, making sure that what is being specified, what is being designed is really going to deal with where we're going with, I mean, whether people believe it or not, with the climate change that we're seeing?
Well, I mean, there's a few things that enter into that. One of the areas that I do beyond my regular duties with Intertek is I volunteer as the vice chair of the USGBC's Resilience Working Group, and we've been developing an understanding about resilience and resilience standards and building that into the new version of LEED version 5 that just came out. Nice. I also volunteer as a co-chair of the American Institute of Architects Resilience and Disaster Response Committee, and we've been working on cataloging and vetting resources both for local as well as national resilience standards and understanding those and making them available both to architects as well as to owners and the public and contractors. So we've been working on keeping up on what's the latest in terms of those standards and what needs to be discussed. And I think one of the key things that's important about keeping up on this is that in addition to thinking about codes and architects' standard of care, we also need to understand that a building even a few years from now is going to be maybe looked at with a different lens than one today, because there are new regulations around disclosure of natural hazard risks, and lenders and investors are starting to then incorporate resilience assessment into their due diligence process at the time of underwriting a loan or deciding to purchase a property. So It could be a liability to design a building today to a code minimum standard as opposed to a higher resilience standard, because 3, 5, 10 years from now, somebody's going to be looking at that building more closely in terms of what are the risks associated with it. So it's important to be keeping up on that. And so one of the things that we've been doing is actually getting involved in that due diligence process and helping investors understand what are the potential risks associated with the building and what kind of considerations should they make at the time of purchase in terms of budgeting and planning for resilience improvements to the existing building over time. And so that element is very nascent, but I see that as potentially impacting the value of buildings in the future. And so it will become a selling point for buildings to incorporate greater resilience.
That is so interesting. I was going to ask you from your experience with USGBC and AIA and the leads, what was some of the key points that you've kind of taken away from the research and the discussions that you're having? And you kind of answered it there, is that requirements for buildings are going to change, and not just by code, but by insurance, by sellers, by maybe even regulations.
Yes, exactly. And I think that people need to be more aware about that and incorporate that thinking into as a not just here's an extra cost I have to bear, but here's a value proposition I can add to the building. Because as you mentioned, Heidi, we're seeing extreme weather events all the time, and everybody from the average citizen to government officials and real estate investors are seeing these impacts and understanding that there are risks associated with this, and they need to act and do something.
Yeah. So, okay. I mean, that just leads me right into where, thinking about these developers, right? Thinking about developers, real estate investors, then general contractors who are building for those folks. And then we get to the subtrades, right? We get to the building envelope, the walls, the cladding, the roofing. So for contractors, as contractors, and, whether they are doing cladding, waterproofing, the roof, how can they communicate this? Because unfortunately, a lot of the contractors who we're talking about in the trades come in later in the process, right? They come in later in the process, but not when it comes to retrofit. And when it comes to restoration, they are definitely on the forefront of working with building owners to talk to them exactly about what you're talking about. Like, what's the value of this building? How can contractors talk to building owners, facility managers, whatever, about resiliency and how important it is, not just for protection and safety of the tenants in the building, but over long-term value of the property?
Yeah, I think that's great, because I think contractors play a really important role in this whole process. And you mentioned retrofits, and so let me start there. I was thinking about that contractors are in this unique position, the ones who work on retrofits or restoration after hazard events, and very specifically, they have seen what goes wrong because they've had to fix it.
Yeah, true.
And so there's a potential wealth of information from understanding that, what are the weak points in a system, where failures occur, and how to avoid those. So there's that element of learning from past work and bringing that forward to proactively address things in the future. And I think about that contractor's role in a couple different ways. I mean, sometimes contractors and subcontractors are in this position where they're essentially following the lead of the owner in terms of what are they asking for and what is their design team drawn and detailed and specified for the project. So they're supposed to build what's on the drawings. But in that role, though, contractors are still a last line of defense where they can look at that and say, well, I can build that, but here's an issue with what's going on based on my experience. And so while that's a reactive as opposed to proactive role, it's still important to raise the red flag in those elements. But I think more proactively, contractors and when subcontractors get brought in as well in a pre-construction services role or in the design and estimating process where they're partners with an owner and a design team, bringing that lived experience with what happens in the field, what's practical to build, what's feasible, what's a more cost-effective way. Because, anything you look at, there's more than one way to solve the problem. And sometimes one way is just as good, but less expensive. And contractors have an important role to be able to talk about that practicality and feasibility element, speaking from experience, to inform design decisions, whether it's in a new construction project or a retrofit.
Yeah. And, I do, when I look at it, I think about what you just said is so true. Contractors see what fails, right? Mm-hmm. They understand what fails and what works. And when you're looking at something as simple as coverboard, right? Really having contractors be educated to be able to talk to their customers about the importance of a coverboard in extreme hail. Or maybe not. Maybe they don't need it if they have more of a build-up system, right? It's just like being able to kind of talk to that point. I think that's an excellent point. Here are the options, but all of these options are resilient. They are going to be able to, and here's the science behind it. It's not just, just because. It's because there's actual science, testing, and results out there that they can show. How can contractors really help to educate themselves more, like working with companies like Intertek or being involved, following some things that are happening with LEED and with AIA? How can they, what's some of your recommendations on how they can educate themselves better to know some of those solutions? They know the problems, they know what's not working, but how do they get more information on some of these resilient products?
Well, I think part of it is being involved with industry associations, and as I've gotten involved in resilience, I'm seeing that people all over the place, from industry associations, product specific associations, groups focused on real estate development, are all talking about resilience, and sometimes in different ways. But there's opportunities to become engaged in those industry conversations and contribute to them as well as learning from them. And then certainly not everybody has the time or is in a location or position to be doing that. But then there are great resources from some states, like state of California, state of Massachusetts, have great resources around resilience. Colorado, because they faced a lot of wildfires, as most Western states has some really good resources around that. And of course, the American Institute of Architects, I'm a little biased because I know exactly what we're doing, but our resources there, while geared towards architects, because that's our membership, are publicly available. And so there's lots of resources for even resilience planning for your own business. So that and that's an important element for contractors, because you mentioned heat domes and extreme heat events, and that's not just an issue, as I mentioned, for designing buildings, but also constructing buildings. Contractors need to have a plan in place for keeping workers safe in extreme heat events, as well as wildfire smoke events. And so it's resilience not just in the materials and construction of a building, but also the process of making a building needs to be considered, and there are resources available for those issues.
Yeah, I agree 100%. I mean, safety right now is key. We're right in the midst of the summer, and we've already seen extreme heat. We're seeing extreme flooding. There is a lot going on that contractors need to be aware of for their own safety and their risk. But I think also building owners and facility managers need to also kind of be working with their contractors hand in hand, and the GCs, in making sure that not only are they making the building safe and keeping it safe for all the tenants and people around it, but they're also keeping their own teams in there. How can, when you really look at understanding those weather patterns and understanding really kind of the risks that go along with it, what are some of the things that can help contractors stay in tune with what's going on with the weather, but also stay in tune on how to deal with some of this extreme weather?
I guess, again, I think that that there are some wealth of resources out there, state and local, as well as some national organizations. I have seen, for example, multiple podcasts and webinars recently focused solely on that aspect of construction workers and extreme weather. I have a friend, Monica Serrano. She has a podcast focused on resilience in the built environment, and she's raised that issue several times in her discussions. And I just saw a post about a webinar that she's participating in coming up that's doing that. So I'd say put up your. I don't have any specific resources to point to today, but I say put up your radar and look for it, and you'll find it. And starting to look on, there's lots of discussion about this on LinkedIn, where you can plug into the current discussion on these issues.
Yeah, and there's so much. So okay, we talk about technology all the time and how technology is going to help. So one of the things that I wanted to ask you about, because I really don't know too much about it, is what are digital twins and how does it use AI in all of this?
So, this is something I was really interested in the topic as well and didn't know much about it. So I've been diving in and learning. So I'm going to share this with a caveat that I'm not an expert in creating digital twins, but I learned a lot about them and I'm excited about the potential that they hold. So let's start with defining what is a digital twin.
Yeah.
And I think in short, the name and it's, as the name implies, it's a digital representation of a real world entity or system. So it could be anything. We're talking about buildings and construction of buildings, but you could have digital twins of in an automobile or in a operating of a company or manufacturing process. The key part is that a digital twin isn't just a virtual model or like a building information model, a BIM. It is typically involves a two-way communication between the real world entity and the digital representation, connected with a pool of both historic and real-time data. So there's this back and forth communication and getting real-time feedback on operations. And to best understand this, I'm thinking about use cases. And so I'll kind of describe that, both current and maybe speculative future use cases. Most digital twins currently are more limited in scope and being implemented for the operation and maintenance of buildings. So it's in the existing building operation and maintenance, things like predictive maintenance of HVAC equipment. When do you need to replace the filters? If you've got a fault and somehow the heating or cooling is not working, helping to identify what's going on and troubleshoot the source of the problem so you can correct it. And so it's a ongoing element for optimization of building operations. And when I think about sustainability and resilience in that standpoint, I think about, as opposed to having set schedules for when the cooling starts going on a building and how much cooling is going into what areas of the building, it can actually be a smart process where you have both historic information about what's happened in the past and current data on both the weather, what's going on with the weather outside in terms of predicted high temperatures and winds and other elements, and also operations. Is this one of those days when everybody's coming into the building, or is this one of those, Friday before a holiday when
it's empty.
2/3 of the building is empty. So can you optimize the building and only heat or cool the portions that are being used, only do it enough to deal with the outdoor conditions as opposed to just a set schedule? So there's a operational efficiency element that then can be leveraged into things like resilience, like a heat dome event or extreme rain or other things like that, to change operation based on extreme conditions that might be coming. But then the use cases, I think, are still emerging. There's an element in construction where a digital twin can go beyond the current software capabilities around things like clash detection that contractors are using to avoid sprinkler pipes and ductwork running into each other, to actually help with optimization of the layout of systems and tracking as-built conditions. So the digital twin can actually be continuously updated as systems are installed, scanning the interior of the building and seeing what's going inside which walls, so that the contractor currently and the owner in the future essentially can have X-ray vision and seeing what's going on in the building, so that they can more easily do modifications and repairs over time. So there's an element to that I think is important. And there's so much to say on this. Sorry,
I love it.
But there's an element that I think is coming in the future. There's a lot of discussion about circularity in buildings. Can you help to make sure that materials at the end of their useful life make it back to the manufacturing process that made them to begin with? And this is easier to think about in terms of a consumer product that has a short lifespan. But when you're talking about buildings where even components and systems in the building might last for 20 or 25 years, and the building is going to be there for 50, 100 years or more, the digital twin can be essentially a catalog of materials in the building, so that at the time of a renovation or repair, you don't have to go searching for exactly what is this material and who made it and what size is it and things like that. But you can actually have a digital catalog of everything in the building. So if something gets damaged in a storm, or the piece of equipment wears out and needs to be replaced, that it's easier to plug and play replacements for those things. So there's both a circularity and a resilience benefit to that. I think finally the last use case that I'm excited about, because I'm passionate about resilience, is this whole aspect about things like anticipating wildfire smoke events where you need to change the ventilation, replace filters more often, other elements like that to protect indoor air quality from very poor outdoor air quality. Or perhaps building in sensors relative to flood control, and so that even a remote operator who's not in the location can tell what's going on relative to extreme rain and potential flooding events, and perhaps implement emergency operational modes to protect from those conditions remotely in a resilience scenario.
Yeah. Wow. I tell you what, we could do a whole one just on this topic, Alan. I'm saying this is
absolutely.
really interesting. And we may have to come back and redo that, because I have to tell you, when I think about, this digital twins, it makes so much sense now to me. Thank you. You explained it perfect. And it really kind of comes back around to the smart buildings. And we're starting to see this from our manufacturers, whether it is having solar capabilities in the cladding, whether it's having RFD codes or chips in the roofing, moisture monitors in the roofing. The whole building pretty soon is going to be wired for one purpose or another. And so being able to monitor that and being able to become predictive with it, so cool. That is going to make such a huge difference.
Yeah, I think that it's so important because right now, architects are using BIM models to design the building, but that BIM model doesn't necessarily translate into what contractors are using for their class detection modeling during construction, so that the software doesn't track through, and then that doesn't necessarily jive well with the as-built drawings. And then when you get into operation, the owners have, their security and access control software and their building energy management software and their software related to work orders for maintenance, and none of those are tied together. They're all discrete bits of software or technology. And so a digital twin has this potential to pull that stuff together and make it more seamless from design through construction and into operation.
Wow. This is how we're going to reduce the risk of this extreme weather, is by technology.
Absolutely.
And being in front of it. That's what needs to happen on the thing. Alan, I can't believe we're coming to the end. This is so great. We'll definitely have you back. We're going to talk more about the technology and the smart buildings. I just think that's in smart construction. There's so much there that we haven't even touched on yet. So thank you so much for being here today on Contractor Outlook Newscast.
Absolutely. I'm excited to continue the conversation, Heidi, and it was a pleasure to be with you here today.
Thank you so much. Wow. And thank you all for listening. Great information, whether you are a contractor doing coatings, with roofing, siding, whatever you may be doing, general contractor, metal buildings, this kind of information of how to battle extreme weather and how to really embrace the technology of smart buildings and smart construction is going to be an ongoing conversation. So stay tuned with us. Be sure to check out all of our Contractor Outlook newscasts under the RLW navigation on all of our sites of the coffee shops. We will be seeing you next time on Contractor Outlook Newscast.